This is a video from section 1.2 in a linear algebra class. To put a matrix in row echelon form or reduced row echelon form, we can perform elementary row operations until we achieve either form. Here are three elementary row operations. Any row may be multiplied by a non-zero constant. So if row n is multiplied by k, we write, so KRN is this part, right? So in other words, we're going to take every entry in row n and multiply by k. And then when I put an arrow, this says essentially put the result back into row n. This will be my new row. Okay? So this is one elementary row operation. Number two, any two rows may be interchanged. If rows m and n are interchanged, in other words, they're switched, we write row m, and this tells me to switch row m with row n. And that will be our new matrix, with that being reflected. Number three, a constant multiple of one row may be added to another row. So if k multiplied by row m is added to row n, we write krm plus rn, and what this arrow tells me to do is says put the result back into, and then I say row n. Okay, now, suppose I want to solve this following system by Gaussian elimination, and I'll explain what that is shortly. Now, I have x plus y plus 2z equals 8. I have negative x minus 2y plus 3z equals 1. And then I have 3x minus 7y plus 4z equals 10. Okay, now this is what I want to do first. I want to write the augmented matrix that reflects this system. And so, in other words, I'm going to construct a matrix as follows. Now, I'm going to read off the coefficients of x, y, and z. And so in the first row, we're going to have 1, 1, 2. In the second row, when I read off the coefficients of x, y, and z, I have negative 1, negative 2, 3. And when I read off the coefficients of x, y, and z in the third row, I have 3, negative 7, 4. And then I'm going to put a dot here, okay? And then these constants will go in the fourth column. So in other words, in the fourth column, I'm going to write 8, 1, 10. Now, in the first row, I want the first non-zero number to be a 1. And we're going to call that the leading one. And since it's already a 1, we don't have to do anything to make that happen. Now, from there, I'm going to use row 1 to make this entry a 0. And then I'm going to use row 1 again to turn this entry into a 0. Now you might ask, well, how am I going to do that? Well, if you notice, if I take row 1 and I add it to row 2, okay, and then this arrow says put the result back into row 2. Now, when I do that, I get the following. Now, are we in agreement that the first row doesn't change? It's 1, 1, 2, 8. Okay, and I'll put the line here, right? The third row didn't change. I'm going to get 3, negative 7, 4, 10. It's the second row that changed. In the second row, if you notice, if I take 1 minus 1, right, if I go entry to entry, that's 0. 1 minus 2 is negative 1, right? And 2 plus 3 is 5. So I get 0, then I get negative 1, and then I get 5. And then from there, I get 9. And I hope that's okay, because 8 plus 1 is 9, right? 2 plus 3 is 5. 1 minus 2 is negative 1. Now, I want this 3, I want to use row 1 to turn that 3 into a 0. That's my next step. So I'm going to use row 1, and I'm going to multiply row 1 by negative 3. I'm going to add row 3, and I'm going to put the result back into row 3. When I do that, okay, I get 1, 1, 2, 8. The second row didn't change. 0, negative 1, 5, and 9. Now, in the third row, right, I'm going to get a 0. I'm going to get negative 10. Then I'm going to get negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. And then I'm going to get negative 14. Just like this. Okay. From there, there's a real strategy to this. Once we have these two entries are as zeros, I want to turn this entry here into a 1, my leading one for the second row. How do I do that? For this one, I'm going to take negative 1 row 2, and I'm going to put the result back into row 2. When I do that, I get 1, 1, 2, 8. 0, 1, negative 5, negative 9. 0, negative 10, negative 2, negative 14. Okay, from here, once we have a leading one in the second row, I want to use row 2 to turn this entry here into a 0. That's my strategy, and I do this routinely. So, in other words, I'm going to take 10 row 2, I'm going to add it to row 3, and I'm going to put the result back into row 3. Okay? When I do that, I get the following matrix. I get 1, 1, 2, 8 in the first row. I get 0, 1, negative 5, negative 9 in the second row. And then let's be careful here. When I take 10 times 1 is 10, 10 minus 10 is 0. So I already know the first two entries are going to be zeros, okay? From there, I'm going to take 10 times negative 5 and get negative 50. Negative 50 minus 2 is negative 52. And then lastly, 10 times negative 9 is negative 90. Negative 90 minus 14 is negative 104. Now, we're almost in row echelon form, okay? Because remember, we're taking the augmented matrix and putting it in row echelon form. So what do? I want to turn this entry here into a leading 1. So I'm going to take negative 1 over 52 row 3. I'm going to put the result back into row 3. Okay, and I'm going to put that dotted line there. So when I do, I get 1, 1, 2, 8, 0, 1, -5, -9, 0, 0, 1, 2. Okay, now we're in row echelon form. And now I'm in perfect position to solve this system. Now, this is what I have. I have 1x plus 1y plus 2z equals 8. Okay? Then I have 1y minus 5z equals -9. And then I have 1z equals 2. And then we can do what's called back substitution, and then we can solve our system. So here, can we agree z equals 2? From there, y minus 5 times 2 equals -9. And that would imply y equals 1. Okay? From there, x plus, and then y is 1, plus 2 times 2, right? And this is equal to 8. So x plus 5 equals 8. So x is 3. And so the solution to this system is the ordered triple through 3. So we got 3 for x, for y is 1, and then z is 2. So that's the solution to the system for example 1. Okay, now let's take a look at example 2. In example 2, it says to solve the following system by Gauss-Jordan elimination. The only difference between example 1 and example 2 is we got to write the augmented matrix and then put it in reduced row echelon form. That's the only difference. Now, this is our system. 2x1 plus 2x2 plus 2x3. This is equal to 0. Then I'm going to have negative 2x1 plus 5x2 plus 2x3. This is 1. And then 8x1 plus x2 plus 4x3 equals -1. Okay. Now, what we're going to do is we're going to write the augmented matrix. If I read off the coefficients of x1, x2, and x3, in the first row, we got 2, 2, 2. In the second row, -2, 5, 2. And again, I'm just reading off the coefficients of x1, x2, and x3. In the third row, I get 8, 1, 4. I'm going to draw this little dotted line here within the matrix, and then I'm going to write the constants on the other side. So it's 0, 1, -1. Okay, now the same rule applies. What I'm going to do is turn that first entry here into a leading 1 using an elementary row operation. So I'm going to take row 1, I'm going to multiply by 1/2, and put the result back into row 1. Now, when I do that, I get the following. I get 1, 1, 1, 0. Then -2, 5, 2, 1. And then the last row is 8, 1, 4, negative 1. Okay, from here, I want to turn that negative 2 into a 0. How do I do that? I'm going to take 2 times row 1, add it to row 2, put the result back into row 2. Now, when that happens, I get 1, 1, 1, 0, 0, 7, 4, 1, and then the third row doesn't change. 8, 1, 4, negative 1. So when you do these, check your arithmetic, because it is easy to make a mistake when you are doing a lot of adding and subtracting in problems like these. Now, I want that 8 turned into a 0. So I'm going to take negative 8 row 1, add it to row 3, put the result back into row 3. So I get 1, 1, 1, 0, 0, 7, 4, 1. And I'm going to put these dotted lines here. And then in the third row, we get 0, negative 7, and then negative 4, and negative 1. So do you notice how row 2 and row 3 look alike? That's good, right? And so what I'm going to do is I want to turn this negative 7 into a 0. And so what I will do from there is take row 2, add it to row 3, put the result back into row 3. And I did that prior to turning that 7 into a 1, only because row 2 and row 3 are just scalar multiples of each other. And when they're scalar multiples of each other, it is easier to get the third row zeros first and then turn that 7 into a leading 1, if that makes sense. So from here, this is the matrix I get. I get 1, 1, 1, 0, 0, 7, 4, 1, and then 0, 0, 0, 0. So we get something like this. Okay? Now, if we write out our system, we get the following. Oh, let's do one last operation. We got a couple of operations first, because we want to turn this into a Gauss-Jordan problem. So I'm going to take 1/7 row 2, put the result back into row 2. So we're almost done. We got 1, 1, 1, 0, 0, 1, 4/7, 1/7, okay? And then 0, 0, 0, 0. Now, if we look at this leading 1, that's the only non-zero entry for that column. But if we look at this leading 1, it's not the only non-zero entry. So then the question becomes, well, how do we fix that? And how we fix that is I'm going to take negative row 2, I'm going to add it to row 1, and I'm going to put the result back into row 1. Okay? Now, when I do that, I get 1, 0, 3/7, negative 1/7. That's the first row. 0, 1, 4/7, 1/7 is the second row, and then 0, 0, 0, 0 is the third row. And this matrix is in reduced row echelon form. So now we're set. Now what is this going to look like? x1 plus 3/7 x3 is equal to negative 1/7. And then I'm going to go x2 plus 4/7 x3 is equal to 1/7, right? Do we match? We do. Now, in here, x3 is a free variable. It can take on whatever value it wants. We have two equations with three unknowns. And if we have two equations with three unknowns, we have one free variable. And how do we address that? Well, I'm going to set x3 equal to, we can call it t. Are we in agreement that x1 is negative 1/7 minus 3/7 t? So I just moved this term over to the other side. And then x2 is negative, well, we'll say positive 1/7 minus 4/7 t. Okay? Now, here's the general solution. So x1, x2, x3. And there's a couple ways you can write this, but for starters, I'm going to write this as negative 3/7 t minus 1/7, right? That's my x1. My x2 is negative 4/7 t plus 1/7. And then my x3 is t. And that'll do it for this video, where we solved two systems of equations one by Gaussian elimination and the other one by Gauss-Jordan elimination. So with Gaussian elimination, we put the matrix, the augmented matrix, in row echelon form. And with Gauss-Jordan elimination, we put the matrix in reduced row echelon form and put that augmented matrix. And so we looked at a couple of examples of that and then looked at elementary row operations. Thank you.